In a world connected by billions of digital interactions, the security of information defines national strength, scientific leadership, and technological sovereignty. As quantum technologies reshape global communication infrastructure, India is building its own future-ready foundation, secure, scalable, and entirely indigenous. The Department of Science and Technology, Government of India, under the National Quantum Mission, took a landmark initiative to launch 4 thematic hubs. Among these, IIT Madras and C. came together to establish the IITM, C. Samgnya Technologies Foundation, India's dedicated thematic hub for the quantum communication vertical. Anchored in this national mission, the Quantum Communication Hub brings together premier institutions, world-class researchers, and strategic partners to advance next-generation quantum communication technologies for India. This thematic hub aims to establish India as a global pioneer in unconditionally secure communication networks. Its mandate spans terrestrial fiber networks, free space links, photonic integrated chips, ground-to-satellite communication, and the development of post-quantum cryptographic protocols-based systems. Through coordinated national efforts, the hub is building the foundation of India's quantum secure communication. At the heart of this initiative are 5 major technical groups, each addressing a critical component of the quantum communication ecosystem. Imagine a future where institutions, enterprises, and critical infrastructure nodes across the country can seamlessly connect to a quantum internet. Robust, secure, and built on indigenous technology. The Quantum Internet with Local Access Group, led by Professor Anil Prabhakar at IIT Madras, is designing this quantum local access framework. Together with collaborators from IISc Bangalore, IIT Indore, CDAC Bangalore, IIT Hyderabad, SETS Chennai, and CDAC Thiruvananthapuram, the group is developing local access quantum nodes, quantum routers, interoperable protocols, and last-mile security.
The quantum communication systems that have been built in this lab have been field deployed as a metro area quantum access network. These networks, what we call as makans, will also be deployed in Bangalore, Hyderabad, Indore, and Delhi. Finally, we expect that we will be able to work closely with our collaborators in other countries and deploy these networks seamlessly across borders so that we are all capable of believing in a quantum secure communication network. As we start to build makans across many cities and connect them together, we come across KILA, or the quantum internet with local access. The cost of deploying something like this across the nation can be quite high. We aim to bring this cost down by building photonic integrated circuits that will not only reduce the cost but also come with a smaller size, lower weight, and reduced power. This will be deployed across all our metro areas and also connect the metros through long-distance links.
The next technical group, towards trusted, node-free hybrid quantum secure communication networks, pushes the boundaries of secure communication by removing the need for trusted nodes altogether. Led by Dr. Bhaskar Kansari from IIT Delhi, this group envisions hybrid discrete variable and continuous variable architectures that enable long-distance, tamper-proof quantum communication. With contributions from IIT Delhi, IIT Roorkee, IISc Bangalore, IIT Jammu, and IISIR Bhopal, the team is developing trusted node-free quantum links that will form the backbone of India's future national quantum communication grid. Long-distance quantum communication requires one essential building block, the quantum repeater. This technical group, Quantum Entanglement Based for Photonic Repeater Advanced Network, led by Professor Urvashi Sinha, is creating India's first multi-node quantum repeater network, enabling entanglement distribution across extended distances. Researchers from RRI Harish Chandra Research Institute, IIT Tirupati, IIT Patna, and IISIR Mohali are advancing repeater designs, entanglement protocols, and deployment pathways that will allow India to build scalable, nationwide quantum networks.
National Quantum Mission for me is not just a mission, it is actually a dream. And I set up the Quantum Information and Computing Lab at RRI Bangalore. It is the first lab in India to work on photonic quantum information processing And since then, we have done many things with single and entangled photons in the domain of quantum information processing, particularly quantum communications. Our focus has been in the domain of long-distance quantum communications because we want secure communications over distances between countries within the country. And we have laid down the groundwork for a lot of these activities from a very early stage. So this gives us a very strong infrastructure for our technology group under National Quantum Mission. We call ourselves QPRAN. We want to infuse life in NQM. That is why QPRAN. So it is Quantum Entanglement Based Photonic Repeater Advanced Networks. So this is a very unique technology group because it is perhaps the most challenging one, in the sense that while we do have the infrastructure for the quantum communications aspects, what is very much missing in research is the quantum memory development. There is no one memory which is a solution to all our problems. So we are going to develop different kinds of memories as a part of the technology group, so that we ultimately have one memory which has the best properties in all its degrees of freedom. For instance, at RRI, we are developing memories based on vacancies in diamond. At IIT Tirupati, we will work on DLCZ protocol on cold atoms, and IIT Patna also cold atoms, but the EIT protocol. Our collaborators will develop warm vapor-based memories. The future is bright, the future is quantum, and this technology group is going to take a leading role in India's National Quantum Mission. We are going to develop different kinds of quantum memories, different quantum repeater nodes, finally culminating with a multi-node synchronous quantum repeater network at RRI Bangalore, which is going to be hopefully a global first.
Cybersecurity in the quantum era demands cryptographic systems that are resistant to quantum attacks. This technical group, Post-Quantum IP Encryptor and TLS Accelerator, led by Mr. Deepak Gaur at CDOT, is developing a suite of indigenous, hardware-level security solutions that include a tamper-proof SCA-FI-resistant 10 Gbps inline network encryptor, a post-quantum TLS E6, PCIe TLS offloading accelerator for high-performance servers. With research contributions from IIT Kanpur, IIT Bhilai, and IIT Kharagpur, the group is building a secure, quantum-resilient cryptographic foundation for India's digital ecosystem.
CDOT has developed a number of quantum security products based on our understanding of the quantum era today. But we don't know what the future may hold, what the actual quantum era will look like. So I feel that the National Quantum Mission will play a very important role here, as it will build up the knowledge base, the research base, the skill base, and increase the level of security, knowledge, and expertise in the country to handle any problems, any threats, any challenges that we may face in the quantum era. We want to draw the best and the most intellectual manpower available in India to take our products to the next level. And we also need the latest technology, the latest components, the hardware and capital items to make new quantum products that can compare with our peers in other countries. I think NQM funding will definitely help us achieve this.
The fifth technical group extends India's quantum communication capabilities to space. Under the leadership of Dr. Senthil Kumar M., the group is designing and demonstrating satellite-based QKD, enabling secure key exchange across thousands of kilometers. Collaborators from the Space Applications Center, ISRO Satellite Center, and IIST Trivandrum are advancing space-grade quantum sources, optical ground terminals, satellite-to-ground QKD links, real-time secure communication protocols. This effort places India among the very few nations pioneering space-based quantum communication, essential for defense, governance, and global connectivity. Together, these 5 technical groups form a unified national framework for quantum secure communication.